Hello everyone, I hope you all are doing fine. My name is Moinak and this is the last part of a 4-part series of Wbpsc Assistant Engineer Civil 2012 paper, and in this video I've tried my best to explain the solution in details as well as the connected questions that might be asked from a particular question is also discussed in details in this particular video. If you are new to this channel and if you like the content of the video, do subscribe this channel and share this with your friends who are preparing for similar government engineering exams in civil engineering. So without wasting any more time, let's start with the question. First question here is the inflection point on the recession side of the hydrograph indicates the. Now let's look into the basic parts of a hydrograph. Now this is the basic part of the hydrograph where the y-axis indicates the discharge and the x-axis indicates the time in hours. So this is the basic parts of a hydrograph. Now from portion 1 to 2 it is known as the rising limb. It is rising limb which is influenced by storm characteristics or the basin characteristics as well. And the part 4 to 5, the part 4 to 5 is known as the falling limb or the recession limb, and this is influenced only by the basin characteristics, now from 1 to 2 or from the point 1, this is the point when the runoff from catchment starts flowing to the river. Now this is a catchment, let's say, or a watershed, and this is the measuring point of this particular watershed, right? And this is the streams from where the rainfall which has fallen to this particular catchment area, it gets collected and it flows through these streams and reaches the measuring point. Now point number 1 is the runoff from catchment starts flowing to the river. In point 2, the runoff from catchment has reached the measuring point on the basis of which the hydrograph was plotted, right? The portion 2, 3, 4 is known as the crest, and point 3 is known as the peak discharge. Now points 2 and point 2 and 4 are known as inflection points, where this hydrograph changes its curvature, and at point 3 the maximum flow rate that has yielded from the watershed has been shown. Point 3 is the peak discharge or the maximum flow rate that has yielded from the watershed. Now point 4, which has been asked in the question, indicates that the rainfall has stopped and the amount of water that enters the measuring point starts decreasing from this particular point. So from point 4, it is understood that the rainfall stops in this particular point and the amount of water that enters the measuring point starts decreasing from this particular point. And the point 5 here, it indicates that only the base flow of the river and the runoff stops at this point. It indicates that after this point only the base flow of the river would be there and no part of the runoff would be there joining the river from this particular point. So these were the basic characteristics of a hydrograph and the basic parts of a hydrograph. So the answer for this particular question is the inflection point on the recession side of the hydrograph, that is point 4, indicates the end of rainfall. The answer should be rainfall. Next question is permanent wilting point is. Now permanent wilting point, what is permanent wilting point? Permanent wilting point is the minimum amount of water in the soil that the plant requires not to wilt, and it is a soil characteristics only, and permanent wilting point depends on the nature of soil, on the texture of the soil, if it's fine grained or if it's coarser in nature. So depends on these following things, and it is a soil characteristics. Next question is the strain energy stored in a simply supported beam of span L and flexural rigidity EI due to central concentrated load W. Now for a simply supported beam with a concentrated load W, the reaction at the supports would be W by 2 here as well as W by 2 over here. So we can calculate the strain energy by this following formula. U is given by integration of m square dx by 2ei. Now for this particular section of a simply supported beam, the sections AC and CB are identical in nature. So in order to calculate the strain energy, we just need to calculate the strain energy in this particular part and then multiply it by 2. Also the reaction here is W by 2, and we just need to calculate the moment at a section XX at a distance x. So the moment here is calculated and comes out to be w by 2 into x. You can see w by 2 into x gives us the moment here. So the strain energy of this whole beam is given by 2 times, because this is a symmetrical section and AC and CB sections are identical in nature. So just multiply it by 2, integrated from 0 to L by 2. These are the boundary conditions, and m here is w by 2 times x whole square by 2ei dx. Now just separate the constants and integrate x square. So just after integrating and putting the boundary conditions, you would get that the strain energy would come out to be w square L cube by 96 EI. 96 EI. So for simply supported beam with point load in the middle portion, the strain energy is given by w square L cube by 96 EI. So the answer should be B. The answer should be B. I would recommend you know how to calculate the strain energy instead of memorizing these particular equations, so that any kind of questions if they ask you, you would be able to answer. Next question is, for a rectangular channel with horizontal flows, the length of jump has been found to vary between. The answer should be from 5 to 7 times. For rectangular channel with horizontal flows, the length of jump has been found to vary between 5 to 7 times the height of jump. Also, hydraulic jumps are classified based on the Froude number. So for undular jump, the Froude number is from 1 to 1.7. For weak jump, the Froude number is between 1.7 to 2.5. For oscillating jump, the Froude number is between 2.5 to 4.5. For steady jump, it is between 4.5 to 9. And for strong jumps, it is greater than 9. So I would recommend remember these as well. These might come in the exams as well. The next question is, a pressure increase of 200 Newton per centimeter square increase the density of water by 0.1%. The bulk modulus of elasticity in giganewton per meter square is given by. Now, as per question, the delta P or the pressure increase is 200 Newton per centimeter square, which is negative. Also, the density of water has been increased by 0.1%. So the increase in density of water is 0.1%. So increase in water is given by delta rho by rho, which is 0.1% or 0.1 by 100. Now you know the bulk modulus is given by minus of del P by del rho by rho is the formula for bulk modulus. So you just put in the values over here and you would get the answer as 200 into 10 to the power 3 Newton per centimeter square. But they want you in giganewton per meter square. So you just change the values from centimeter square to meter square. Just divide it by 10 to the power minus 4. It would come out to be 2 into 10 to the power 9 Newton per meter square, which is 2 giganewton per meter square. So the answer should be 2 giganewton per meter square. So the answer should be C. The next question is, the hydraulic loading rate in meter cube per meter square per day with recirculation ratio of 0.5 for a trickling filter of 30 meter diameter and 2 meter depth to treat a flow rate of 6000 meter cube per day will be. Now you know the flow rate is given here as 6000 meter cube per day, and the area of trickling filter is given by pi by 4 d square, where d is 30. So the area would come out to be 706.86 meters square. Also, the hydraulic loading rate is given by Q plus QR by area. Where the recirculation ratio is given by QR by Q. Just replace the recirculation value here, 0.5 equal to QR by Q, and QR comes out to be 0.5 Q. So just replace the values in this particular formula, and the hydraulic loading rate would come out to be 6000 plus 0.5 times 6000, because QR is 0.5 times Q, divided by area. The answer would come out to be as 12.73 meter cube per meter square per day. The nearest answer is B. The nearest answer should be B. Next question is, a butt weld is specified by its. Now a butt weld is specified by its effective throat thickness. Next question, the velocity potential of two-dimensional flow is given by phi equal to x times 2y minus 1. The velocity at point 22 is given by. Now the velocity potential is given here, phi, which is 2xy minus x. So the component of velocity in x direction is given by minus d phi by dx. Just need to differentiate with respect to x, and this would be the values. Now at point 22, the velocity component at x direction comes out to be minus 3. Similarly, the velocity component at y direction comes out to be minus 4. So the actual velocity would be the square root of the ux square plus ui square. So the answer, if you replace the values, would come out to be as 5 units. The answer would be 5 units. So the answer for this particular question should be C. The answer for this particular question should be C. Next question, the specific energy in a channel is defined as now the specific energy is defined as the sum of velocity head and the depth of flow, which can also be written as the sum of velocity head as well as the pressure head. The depth of flow can also be written as the pressure head. You know, specific energy, it is the total energy with respect to channel bed as bottom, or it is the distance between the total energy line and the channel bottom. Mathematically, it is given by E equal to y plus v square by 2g. Pile foundations are normally used in. Now, pile foundations are normally used in soft clay soils where the bearing capacity is not enough. So pile foundations are basically a type of deep foundation where the depth of foundation is much greater than the width of foundation. Also, it is typically used in cases where the top part of soil is weak and with low bearing capacity. Also, piles transfers the loads coming from the superstructure to the hard strata with high bearing capacity. So the pile, if this is a pile and the surface soil is weak in nature, so piles transfer the load from the superstructure to the hard stratum, where the bearing capacity is enough to deal with the structural loads. So the answer should be soft clay soils. Next question is the main constituent of varnish is resins. Now what is a varnish? Varnish is actually, it is primarily used in wood finishing works. Where the natural tones and grains in the wood are intended to be visible, and it is applied over wood stains as a final step to achieve a film for gloss and protection. Now there are various types of varnishes: oil varnishes, spirit varnishes, etc. And resin is the main part, which you already know. The next question is the two small orifice A and B of dia 1 cm and 2 cm respectively placed on the sides of a tank at depth H1 and H2 below an open liquid surface. If the discharge through A and B are equal, the ratio of H1 and H2 R will be. Now this is a tank where A and B are the two orifices that are mentioned in the question, and this is the water level HA. The orifice A is at a height H1 and the orifice B is at a height H2. Now this is A, this is B. The diameter is given as 1 centimeter and for this it is 2 centimeter. The height is given as H1 and here is H2. Now the discharges are equal, which is already given in the question. Now you know discharge is equal to velocity times area. So this will also be equal in both cases. So we just equate it like this: VA by VB is equal to AB by AA, where V is the velocity and A is the area of the orifice. Now we just replace the velocity by root 2GH in each cases, and the area by pi by 4 d square respectively. So after cancellation, the equation comes out to be root over h1 by h2 is equal to d2 by d1 whole square. So h1 by h2 would come out to be d2 by d1, which is d2 over here is 2 and d1 here is 1. So the answer h1 is to h2 would come out to be as 16 is to 1. So the answer would come out to be as 16 is to 1. The option is A. The correct option is A. The next question is, if x component of velocity u is 6xy minus 2x square, then the y component of low velocity is. Now the x component is given here as 6xy minus 2x square. Now according to the continuity equation, considering the flow is steady and incompressible, du by dx plus del v by del y plus del w by del z is equal to 0. Now this is a 2D, so this would come out to be 0. Now del u by del x is written as del x of 6xy minus 2x square plus del v by del y equal to 0. Now just differentiate with respect to x and it would come out to be as 6y minus 4x plus del v del y by equal to 0. So del v by del y equal to this portion, you just put in the negative sign over here. Now v would come out to be as the integration, of minus 6y plus 4x. So just integrate the values and come out to be as minus 6y square by 2 plus 4xy plus the c, which is the constant. Neglecting the constant value, the answer would come out to be as minus 3y square plus 4xy. So the answer should be minus 3y square plus 4xy D. Next question is, a geotextile when placed in between a fine soil and a coarse material performs the function of. Now, geotextile performs the function of a lot of things. In this case, it performs the function of separation. In this case, it performs the function of separation. Now, let's look into the other functions that the geotextile plays a role in. Now, geotextiles acts as separation when it should preserve the mechanical characteristics and properties of two different soils of different particle size distribution, right? It acts as reinforcement when it takes up the tensile stresses and distributes them more easily. It acts as protection when it absorbs local stresses and distributes them more evenly, protects against perforations of impervious film sheets and asphaltic membranes. It performs the function of filtration when it is in contact with natural soil. It should prevent erosion and uplift. It performs the function of drainage, and it should have a high porosity when it performs the function of drainage. So geotextile performs a lot of functions, but according to this particular question, it acts as separation. Next question is, the mean velocity of flow of air in a ventilating duct of 1 meter is 33 meter per second, and the maximum velocity is 20 meter per second. Corresponding Reynolds number is, the kinematic viscosity of air is given as 0.165. Now the kinematic viscosity is given as 0.165. Let's take it as Stokes. So you convert it into meter square per second by multiplying by factor 10 to the power minus 4. Now the Reynolds number is given by Vd by nu, where nu is the kinematic viscosity. You just replace the values on the answer should come out to be as 2 into 10 to the power 6. 2 into 10 to the power 6 is the answer for this particular question. Next question is, it is seen from laboratory results that 10 milligram per liter of chlorine will be needed for breakpoint chlorination of a particular water sample. To maintain 0.4 milligram per liter of free chlorine residual in the disinfected water, the requirement of chlorine in kilogram per day for a flow rate of 2 million liters per day is. Now, the total chlorine required here would be, 10 plus zero point 0.4, where zero point 0.4 is the need for to maintain it for free chlorine residual in disinfected water. So the total chlorine required should be 10.4 milligram per liter. Also, the flow rate given here is 2 million liters per day. Now, 2 million liters per day means 2 into 10 to the power 6 liters per day. So, the total chlorine required in kilogram per day would come out to be as 10.4 into 10 to the power minus 6 when you convert it into kg per liters, into 2 into 10 to the power 6 liters per day. So, this and this cancel. So, the answer comes out to be 20.8 kilogram per day. So, the total chlorine required should be 20.8 kilogram per day, which is option B. Next question is, road markings with a combination of broken and solid lines indicate. Now let's look into the road markings combination, right? Now first things first, the white lines. When you are traveling in a vehicle, the white lines indicate that traffic is traveling in your direction, and the yellow lines, these indicate, they mark the center line of a two-way road used for two-way traffic. Now broken lines, these indicate that it is permissible in nature and allows crossing with discretion if traffic situation permits, right? One solid line indicates that it is restrictive in character, does not allow crossing except for entry exit from a side road to avoid a stationary obstruction. Now, two solid lines indicate there is severity in restriction and should not be crossed except in case of emergency. You should not be crossing two double lines. And one solid line and one broken line indicates that in such a case, a solid line may be crossed with discretion if broken line of combination is nearer to the direction of travel and vehicles from the opposite direction are not allowed to cross the line. So if a vehicle is moving from this direction, and if the broken line is nearer to the direction of travel, then according to the discretion of the driver, it can cross this particular line. But if a vehicle, this was the vehicle, let's say, and if a vehicle is moving from this direction, he cannot cross this particular line. Because a solid line is here. But if you have a broken line, when two lines are there, and if you have a broken line which is nearer to the direction of travel, then according to the discretion of the driver, you can cross this particular line. So the answer for this particular question should be Solid line may be crossed if broken line is nearer to the direction of travel. So the answer should be D. The answer should be D. The next question is, which of the following condition is to be satisfied both in elastic and plastic analysis? Now the conditions which need to be satisfied for elastic and plastic conditions is obviously the equilibrium condition. Next question, in bituminous mix, if void space is kept very less, the distress that may occur is. Now if void spaces are kept very less, the distress that occurs is known as fatty surface, Now let's look into the other options as well. Now hungry surface, these are characterized by loss of aggregates from surface or appearance of fine cracks. The causes of this is the use of less bitumen in the surfacing is the main cause. Now fatty surface, it results when bituminous binder moves upwards in the surfacing and collects as a film on the surface. The cause is excessive binder in premix surfacing overfilling the voids. Next is streaking. Streaking is characterized by appearance of alternate lean and heavy lines of bitumen either in longitudinal and transverse direction. The main cause is results when alternate longitudinal strips of surface containing different quantities of bitumen due to non-uniform application of bitumen across the surface. And slippage is due to the relative movement of surface layer and the layer beneath it. Main cause is unusual thrust of wheels in a particular direction. The option for this particular question should be fatty surface. The next question, an artificial stone made from pieces of marble and cement and used for floors, facing of walls, etc. is known as. Now the two options given here, marble as well as terracotta. Now marble is a natural stone, so this option won't be correct, right? And terracotta is a type of earthenware, so this option also goes out of the picture. Now the question arises between these two options, A and B. Now mosaic as well as terrazzo, they both are made up of marble and cement. So this particular question, both the answers should be correct. Because both these flooring styles are made up of marble as well as cement. Mosaic as well as for terrazzo. But a lot of books, they have chosen this particular option, terrazzo, as the answer. But both the options are correct according to my opinion, because both of them have cement as well as marble in their styles of flooring. So you could choose any of these two, but you can, most of the books, the answers is given as terrazzo flooring. Next question is, the compressive strength of concrete determined from a 15 centimeter into 15 centimeter cylinder as compared to that from 15 centimeter into 30 centimeter cylinder is. Now if the cylinder is smaller, the compressive strength is more. Also, if the length or the height to dia ratio is 2, then the smaller cylinder will obviously give higher strength. But if the height to dia ratio is less than 2, then certain correction factors are introduced in this particular compressive strength calculations. Now cylinder gives more appropriate result for uniaxial compression of concrete, but in India we use cubes. For calculating the compressive strength. Also, cubes of smaller size, let's say 100 millimeter, gives more strength than standard cubes. This is very important. The characteristic compressive strength of cube is almost 1.25 times the characteristic compressive strength of that of cylinder. Now this is the graph that shows that is plotted between the percentage of strength, where h by d is equal to 1, the height to dia ratio, and the height to lateral dimensions is given here. And for cylindrical specimen, this graph is followed. This particular graph is followed. So as you can see, if the height to dia ratio is 2 and if the height to dia ratio is 1, in this particular case the strength would be more in cases of cylinder, which is given here 15 into 15 centimeter. 15 into 15 centimeter is this case, and for this particular case it is 30 or 15 into 30 centimeter, or 30 into 15 centimeter, whatever you call it. So for this particular case, 15 into 15, the compressive strength should be higher. Next question is, flow mass curve is the graph between Flow mass curve is the graph between cumulative discharge and time. Next question is minimum value of super elevation of a road with premix carpet surfacing is. Now we have to keep a minimum value for super elevation because of the drainage conditions, to allow the to not allow the water to stay in the roads. We need to have a minimum super elevation of every road. So the minimum super elevation is equal to the value of camber of road, and this is the E minimum, this is the E max. The ones which we provide is known as the E provided, which should be in between E minimum and E max. Now the camber as per IRC is given by this particular chart, right? So for cement, concrete or high bituminous type, for thin bituminous type, for WBM gravel roads and for earth roads. But for premix carpet surfacing, the road surfacing that is used is thin bituminous types of roads, and the minimum super elevation or the camber here is 2%. So for the answer, and the camber is equal to the minimum super elevation, the answer for this particular question according to me should be 2%. For this particular question. Next question is in chute spillway. Flow is usually, now in chute spillway the flow is usually super critical. Now let's look into what is a spillway. A spillway is a structure used to provide the controlled release of flows from a dam into a downstream area. A chute spillway is an open channel-like structure which is constructed on steep slope on the gully face with a suitable inlet and outlet. Also, chute spillway leads the water from the reservoir to downstream, and the slope of chute should be high enough to maintain supercritical flow to avoid any unstable flow condition. The answer should be in chute spillway flow is usually supercritical. Next question is a sample of water contains the following: Ca2 plus ions as 200 milligram per liter or as CaCO3, magnesium 2 plus given as 1 milli equivalent per liter, different unit is given here, and sodium is given as 75 milligram per liter as CaCO3. The total hardness of water sample is. Now what is total hardness? Total hardness is caused due to the presence of multivalent cations in water. So the sodium part is not required. For calculation of hardness. So the parts that are required is for calcium as well as magnesium. Now calcium is given as 200 milligram per liter as CaCO3, and magnesium is given as 1 milli equivalent per liter. Now to convert 1 milli equivalent to milligram per liter, you just need to multiply it with the equivalent weight of CaCO3. In this case it is CaCO3 and the equivalent weight of CaCO3 is 50. So you just need to multiply 1 milli equivalent into 50, which is the equivalent weight of CaCO3, which comes out to be 50 milligram per liter as CaCO3. The total hardness should be 200 plus 50. This is for calcium and this is for magnesium. So it should be 250 milligram per liter as CaCO3 or 250 by 5, which comes out to be 5 milli equivalent per liter as CaCO3. So both the options are correct. So the correct option here should be 5 milli equivalent per liter. So the answer should be 5 milli equivalent per liter. So this was the final part of the 4-part series of the 2012 Wbpsc Assistant Engineer Civil paper. I hope this is helpful for students who are preparing for this examination as well as other civil engineering government exams. And if you like the content of the video, do share it with your friends who are preparing for similar government engineering exams in civil engineering. And stay safe everyone. Study hard but study smart. And thank you.